Hey guys, so we've reached the finale of our adventure with logarithms and exponentials, at least for now. So we've seen exponential modelling and we've seen exponential graphs. Now their graphs are not really that handy to read. Often when their gradient is so huge, reading an accurate result from the graphs is quite tricky. So what we can do is take these exponential functions and transform them using logs into a linear form. So believe it or not, we got these two guys here that look completely mental, but we can compare them to y equals mx plus c. Now I'm going to show you how, first of all, and then I've got an exam question to finish us off. So, first of all then, let's look at exponentials of the form y equals ax to the power of n. So, if we were to log both sides, we would get log y equals log of ax to the power of n. Now, on the right, using the laws of logs, we can split that up. So we're going to get log y is equal to, now I'm going to write it this way around, log x to the n plus log a. Remember, if you add logarithms, and they've got the same base, you multiply the thing being logged. So we've just done that backwards, we split it up. Now, what we've got here, log of a is just going to be a constant term. Now, what we can do now also using the laws of logs is rewrite log of x to the n. So we get log y equals n log x plus log of a. Now, because everything is a log term, this is actually a straight line. So, if we compare this to y equals mx plus c, well, log y is our y term, n is our gradient m, log x is our x term, and then our constant at the end, our y-intercept, which would actually be our log y-intercept here, is log a. Now I think it's probably worth mentioning here too what our axes would be labelled as. So they're not just y and x. We would have log y going up the side and log x going along the bottom. So like I said, our constant term at the end is not a y-intercept, it's a log y-intercept, because it's crossing the log y axis. Good times. Okay, very similar situation with y equals k b to the x, except here x is the power. So, if we log both sides, we get log y equals log of k b to the x. So just like last time, we can split that log on the right using the laws of logarithms. So we get log y equals log of b to the power x plus log k, and then again using the power law of logs, we can get log y is equal to x log b plus log k. So what's going on here in terms of, if we compare it to y equals mx plus c, well, this time, again, our y is now log y. In terms of the mx part though, m is now log b, so that's a constant, and x is just x this time, and then our plus c is our log k term. So this time our axes are going to be log y, where y usually is, but just x going along the bottom. Okay, so now we're going to take a look at an exam question using this stuff. Okay, here we go then. So, a student conducts an experiment and records data about two variables, x and y. So we got our values here in the table. The student is then told that the relationship between x and y can be modelled in the form y equals k times b to the x. Now part A asks us to plot the values of log base 10 of y against x on the coordinate grid down below. So we're going to need to fill in these values in the table, use your calculator, and you should get these. Okay, here are the values that we should get then. So it's worth noting here that the relationship between x and y is definitely not linear. Look how much bigger and faster y is getting than x. So we're definitely dealing with exponential stuff here. So those are the values that we should get. If we then plot them down below, just be aware of what our axes are. So going on the side, we have log 10 of y, and along the bottom, we just have x. So plotting our values, we should get something that looks like that. Then we're asked to state with a reason which piece of data is likely to have been recorded incorrectly. So if we were to draw a line of best fit, if you like, we would get something that looks like that. Now there's one value that doesn't really fit very well with that straight line, and that would be this guy right here. The rest of them pretty much sit on the line or are incredibly close. This guy though is pretty far away. So our data point then would be 4, 3. But the question actually asks us for the value of y that is likely to have been recorded incorrectly. So that's going to be this chap here. So that would be our actual answer. Okay, now for the fun bit. So it says by drawing an appropriate straight line, find values of k and b. So the appropriate straight line is the one that I already drew, the one that joins up the most points. So this guy. What we're going to do, before we use our line though, we're going to do the transformation. So the graph is in terms of log y, so we need to turn y equals kb to the x into log form. So log both sides log y equals log of kp to the x. Now we've already seen this earlier in the video. This can be written as log y is equal to x log b plus log k. So what are we finding here then? Well, log b is gradient and log k is the intercept on the vertical axis, so it's the log y intercept. You can still really just think of it as the y-axis intercept though, because really that's what it is in terms of the drawing anyway. So we can find that guy nice and easily. It would be this point here. So I would say then log k is, or roughly, it's not quite 0.6, it's a bit above, so I'm going to go for 0.65. So if log k is roughly equal to 0.65, then we know k is, well, to undo the log, remember we're dealing with a log base 10 here, so to undo the log we would do 10 to the power 0.65, so k is equal to 4.7 if I go to one decimal place. So this is one of those questions where everyone's going to have a slightly different straight line, so there is an error interval for the answers here. Okay, now let's find the value of b. Okay then, now we need to find the value of b. So remember here that log b is the gradient. It's multiplying the x term. So what we need to do here is get our best estimate of the gradient. So to get that, we are going to consider the 2 points furthest away. So that's when x is 1 and when x is 6. Remember, the points are not in an exact straight line, so this will give us the best estimate of the most accurate gradient. So also remember, gradient is the difference in y divided by the difference in x, except here we are not interested in the y values but the log y values. So we're going to do log b is equal to 3.5. So that's the log value at x equals 6 minus the log value at x equals 1, which is 1.1. So we got 3.5 minus 1.1 over the difference in x. 6 take 1 is 5. So if you put that into a calculator, you will get 0.48. So now we know log b is 0.48. So now we need to undo the log to get what b is. So remember, this is log base 10, so we get b is 10 to the 0.48 8, which is going to give us a nice answer of 3. So there we have it, we found our values of B and K. Jobs are good for this video at the moment, jobs are good for this chapter. Hope it's helped. Take care guys.